Hello everyone, welcome back to my channel. Today we are continuing our study of data science concepts applied specifically to legal and complaint analytics. So, in this lecture, we are going to cover an important topic from part C, which is data pre-processing for complaint analytics, including data quality issues, handling missing values, smoothing techniques, schema integration, normalization, billing of case severity, and feature selection methods. So, let's begin with the first part. So, here's part C of question paper data science. Data pre-processing for complaint analytics. So, question number 1 here is discuss accuracy, completeness and consistency issues, missing timestamps, contradictory narratives, mistyped section, propose two more quality dimensions relevant to legal analytics. Depends on timeliness, verifiability, provenance. So, for this question, for question number 1, data quality refers to whether the information stored in complaint database correctly reflects the real world. So, we have three core problems. First one is accuracy, second one is completeness, and third one is consistency. So, basically accuracy means the stored value match reality. Sometimes complaint data may contain mistyped section, incorrect crime location or extra zeros and momentary loss. So, basically these errors lead to wrong risk predictions and wrong section mapping. For this accuracy is used. Second one is completeness. Completeness refers to whether essential fields are present or missing. So many FIRs may miss timestamps, addresses, GPS location, witness details or digital evidence links. So if essential fields are missing, the system cannot classify or route the complaint correctly, right? So third one is consistency. Consistency means the same information does not contradict itself across different sources. So for example, a section numbers differ between EFIR and physical FIR, or monetary loss is updated in one place but not in another. This creates ambiguity for analysts and for the DSS. Additional dimension here is two additional dimension, timeliness and verifiability. So timeliness, complaint data must be updated quickly when new evidence, new witnesses or revised section appear. So if updates are slow, system may make decision based on old information. Another one is verifiability and provenance. So every value should be traceable to its original sources such as FIR text, witness statement or scanned document. This improves legal reliability and auditing. So these are the main data quality concern in complaint analytics. So for next question, here question number 2 for handling missing values and extracted feature, discuss approaches, ignore tuples, manual completion, constant field, mean, median, mode imputation, class specific imputation, by offense category, most probable value, model based. So in this question, complaint dataset often have missing entries. So there are several ways to deal with this. We can ignore tuple, manually complete records, assign constant values or impute using mean, mode, median, or predict missing values using machine learning models. Sometimes we use different imputation for different offense categories. For example, monetary loss in cyber fraud is usually higher in petty theft. So median value should be chosen separately over there. So handling missing value in extracted feature. When features are extracted from FIR narratives or forms, some values will be missing or unknown. So these are the common strategies written here. So after reading all this, we are moving ahead. So often practical pipelines use a combination. For example, constant or mode for low importance field, class specific model based imputation for critical attributes such as loss estimate or injury severity. So these are basically the types, means how the missing values are often not ignored. Sometimes to ignore missing value makes the decision or result wrong, right? So that's why these are the techniques used for handling the missing values. So moving ahead with the next question. Here question number 3, smoothing expected scores, use the evidence strength list from E2. So smooth using bin means with bin depth 3, show steps, suggest ways to detect outliers. C, discuss other smoothing methods such as beam medians, low smoothing averages, robust estimators. So for this question specifically, what we have to do, like, for section C, sometimes we calculate the evidence strength scores and want to smooth them. So method 1 is beam means. We first sort the values, then divide them into bins of size 3, then replace each bin with its mean. So this helps remove small fluctuations and noises. Second method is detecting outliers. So basically we detect outlier by z-score. Z-score is a value. So we detect outliers by z-score, IQI scatter plots or distance methods. Specifically in complaint analytics, we want to identify cases with extremely high impact but very low evidence, which might indicate spatial circumstances. So here are some other smoothing methods also present. So we also have mean median, moving averages, Loess regression, robust estimators like trimmed mean or MAD based method. These reduces the influence of extreme values and produce the smoother patterns. So basically in this question, assume we have a numerical list of evidence strength or impact scores. So we want to smooth the series to reduce noise and highlight the general patterns. For this, there are several methods like smoothing using bin method, then detecting outliers, visual methods like box plot and scatter plots, distance based method like if we are talking about distance based methods, consider each complaint as 2D point, impact and evidence. Compute distances from the cluster center using Euclidean distance. Complaints with distances far larger than typical are marked as outliers. So this is called the distance based method. Like this, we have some another methods as I already told you, just mean median, moving averages and like this. So in last we have some another method which is also called Winsorizing is another technique. Extremely high low values are replaced by chosen percentile. For example, 5th and 95th, preventing them for distorting the overall pattern. So these are the techniques which we are used for handling outliers. Now next question, discuss schema integration, handling redundant entries, duplicate across EFIR and physical logs and resolving value conflicts. For example, differing monetary laws or section limits. Here in question number 4, basically schema integration, redundant entries and value conflicts. So in complaint analytics, data arrive from multiple operation systems like EFIR portal, station house registers, physical FIR scans, helplines and court orders. Pre-processing must integrate these into a unified scheme. So for this, since complaint and data comes from various sources, we match field names, merge duplicates records, and resolve data conflicts. For example, if different records show different monetary laws, we must decide which one to trust using rules like source priority, most recent update, majority agreement, or confidence rating. So here are some schemas written here. Schema integration like align attribute names and meaning across sources. Second one is handling redundant entries, duplicate records, like the same complaint may appear multiple times. Once in online FIR, then again in physical FIR, so yet again in the station diary. So detect duplicates by comparing combinations of FIR, like FIR number, complainant name, date time, police station, narrative similarity. So once duplicates are detected, either merge them into a single master record, or keep one as a primary or mark other as a references. So these, these avoid double counting in statistics. Like this, we have some another methods like resolving value conflicts. So after this discussion, now we are moving forward for the next question. Explain the normalization methods for feature scaling. So question number 5, explain normalization methods for feature scaling. First one is min-max normalization, z-score normalization, z-score using mean absolute deviation and decimal scaling. For this, question, normalization, binding and feature selection are there. So normalization means scaling a number to a comparable range so that one variable doesn't dominate others. So when different numeric features have different scales, model that uses distance or gradient based optimization can be biased. Normalization rescales features into a comparable range. First one is min-max normalization. Here in min-max normalization, we subtract the minimum and divide by the range. So values become 0 and 1. This is useful when data has clear minimum and maximum. Option number 2, z-score normalization. So here, idea here is transform value so that new distribution has mean 0 and standard deviation 1. So basically, we subtract the mean and divide by the standard deviation. This gives value measured in standard deviation from the average. These are the techniques how we are going to solve these questions. And here is the formula written on the screen. You can check out from there. Also about mean max normalization, this is the formula. So after these two techniques, we have another technique called Z-score using mean absolute deviation, also called MAD. Okay. So standard deviation heavily weights large deviation like for attributes like loss of few extremely high cases can inflate sigma. Mean absolute deviation gives a more robust scale. Basically, this uses mean absolute deviation, which is more robust than when outlier exists. I get it. So this scaling is more stable for highly skewed data like Monterey loss. So for that, here is the formula. Next is decimal scaling. Last technique called decimal scaling. The idea for this, move the decimal point of value such that all lie in the convenient range. Usually the range is from -1 to +1. Basically, we divide by the appropriate power of 10 so that value fall between -1 and +1. This is a very simple and useful when numbers vary by order of magnitude. Begin with the question number 6, binding case severity scores. So we have some given scores written on the screen 5, 10, 11, 13, 15 and so on. They are already in ascending order. So there are n equal to 12 values. We partition these scores into bins using three approaches. First one is equal frequency, also called equi-depth bins. So basically goal is to each bin contains the same number of data points. So if we choose 3 bins, depth equal to 12 divided by 3, which is equal to 4 values per bean. So bean 1 lowest severity, first 4 values, then medium severity, next 4 values, and like this we have bean 3 highest severity, have last 4 values. So each bean contains 4 complaints. After this we have another technique called equal width bin. So this technique is used to divide the range of values into intervals of equal width. Basically minimum 5, maximum 215, range 215 minus 5, 210. So 3 beans width equal to range divided by 3. Also here width की value width equal to 70. So define beans including left boundary excluding right except last bean. So we divide the numeric range into equal intervals, but these may give very unbalanced bin if data is skipped. So like in this example, where most values fall into the first bean. So basically here we got some values after calculating. So most complaints fall into the lowest severity bean, only 1 into the medium bin and 2 into the high bean. So these unbalanced bin, these are the unbalanced bins. Now moving ahead with the C, clustering based bins. Example K means with K equal to 3. So form bin that represent natural clusters of severity values rather than equal counts or equal ranges. So running K means we see 3 natural groupings, smaller number, medium and extremely large. So a reasonable clustering result. So basically clustering based we use K means or similar clustering so that natural group appears. So this gives meaningful categories like low, moderate and extremely severity. So according to these categories we have decide our bean. So we have assigned the values as well as so these clusters align with intuitive jumps in severity. So why it is important? So different beans may correspond to different sections. Mapping threshold, for example, low severity routes to normal procedure, high severity goes automatically to fast track, extreme severity might trigger senior review. So binding directly affects legal decision making. Here the end of question number 6 is done. Now moving ahead with the next question number 7. Question number 7, feature selection for section mapping summarizes with a flowchart the technique for choosing attributes used by the DSS. First one is forward selection, backward elimination, and C is hybrid method. So basically feature selection for section mapping. A decision support system DSS for section mapping may have many potential features, evidence score, number of witnesses, prior history, age of victim, monetary loss, location type, weapon used, etc. Too many irrelevant features can cause overfitting and slow models. Feature selection chooses a useful subset. We summarize 3 strategies using a textual flowchart description. So a DSS might have many variables. We must select the best one. First technique here is forward selection. So start with none. Keep adding the best features until improvement stops. So imputation is gradually builds up from the most informative features, making the process interpretable. So these were the first features selected. This is the technique flow of algorithm written here. You can read this out. After this, we have another technique called backward elimination. So flow of the algorithm is written on the screen. Backward elimination basically starts with all features, keep removing unimportant features. So just opposite of forward selection. Right. So what is the intuition here? Start from a rich model, keep shaving away redundant or noisy features. Here is the algorithm you can check out. The last one is hybrid methods. What's the idea? Combine advantages of forward and backward search. Typically hybrid, you know what? Hybrid method is combining both methods by adding and removing features step by step. So this gives more flexibility and better final results. So here the advantage is more flexible search of the feature space than purely greedy forward and backward. Can adapt when interaction between feature means that a feature is useful only in combination with others. So basically, in this lecture we studied data quality issue and complaints, handling missing values, smoothing numerical scores, schema merging, normalization, binding and feature selection techniques. All of these tasks are extremely important before any model or DSS can be deployed in real world legal systems. So thank you so much for watching this video.